Betelgeuse is a renowned red supergiant star known for its massive size. If you were to place it where the Sun is, it could potentially expand to the orbit of Jupiter. This star is enormous, highly unstable, and on the brink of exploding. The possibility of Betelgeuse exploding at any moment has been a topic of interest. Betelgeuse is both fascinating and mysterious, located in the Orion constellation. This red colossal star exhibited unusual behavior when it dimmed significantly in late 2019 and early 2020, reaching levels of faintness not seen in over a century. It briefly became as dim as Bellatrix, Orion's third brightest star. This dramatic dimming event led to its nickname, but Betelgeuse has since regained its brightness, even outshining other stars in Orion for a few days this year, becoming brighter than ever before. Speculation about its potential destruction in the form of a supernova has arisen from these incidents. However, is there any evidence to support this theory? Will the purple supergiant Betelgeuse explode within our lifetime? And what impact would such an explosion have on Earth? Let's delve into the possibility of Betelgeuse becoming a supernova and what Brian Cox has to say. Brian Cox warns that since humans might be the only sentient species in our galaxy, the destruction of our civilization would have catastrophic consequences across the entire galaxy. Cox explores the Goldilocks principle in the universe, suggesting that specific conditions over billions of years have made Earth suitable for significant life to emerge. Although the star at the center of our solar system has not undergone significant changes in nearly 4 billion years, scientists estimate that it is currently about halfway through its life cycle. It transforms 4 million tons of matter into energy every second by fusing 600 million tons of hydrogen into helium. This warm plasmasphere is the primary energy source for life on Earth. However, scientists anticipate that in about 5 billion years, it will evaporate, causing a significant alteration in the universe. Cox has also discussed this in the BBC's Wonders of the Universe series. The universe may seem static, but stars are merely transient features of the sky. Despite shining brightly for thousands or even billions of years, their lifespan is limited by their ability to maintain hydrogen. A star like our Sun begins to die when its hydrogen runs out. However, the Sun will not disappear peacefully. Its outer layers will expand as its fuel depletes, causing its core to collapse and produce more heat. Cox warns that the effects of the Sun's changes will be felt on Earth much sooner. He suggests that in about 1 billion years, there could be a final extremely hot day on Earth, rendering life unable to survive. The Sun may expand to the point where it fills the entire horizon, and eventually human existence will be gone. In its final stage of development, we will see it become a red giant. However, the Sun will continue to evolve long after humanity has vanished. Our planet might not last this long, but if it does, it will witness the final stages of our star's demise. The Sun will eventually explode, releasing vast amounts of gas and dust into space, creating a massive nebula. It will likely be a dim ember at its core, a fraction of its former brightness and size, smaller than Earth. Our Sun might become a white dwarf, although this process would make life on Earth possible. NASA's New Horizons Mission Chief Investigator Dr. Alan Stern has mentioned that it could also create habitable worlds in the coldest regions of space. Dr. Stern believes that any remaining humans might find refuge on Pluto or other distant dwarf planets within the Kuiper Belt, a region of icy objects beyond Neptune. These worlds' environments will change significantly as the Sun expands, becoming less hospitable over time. Stars generally maintain a constant brightness, but some, known as variable stars, exhibit changes in brightness. One such star, known as Maya, was identified in 1596 by German priest David Fabricius. Maya is a pulsated star that periodically expands and contracts. Another example is Alol, which experiences periodic eclipses by a companion star. Approximately 30% of these variable stars are observable from Earth, although it requires expertise to detect their brightness variations. Betelgeuse, even if you don't know the term, is one of the brightest stars in the night sky, forming a prominent part of the Orion constellation. Betelgeuse is so large that it could easily engulf Earth, Mercury, Venus, Mars, and possibly even Jupiter if it were placed at the center of our solar system. Its distance from Earth is significant, but its size and brightness make it a subject of study. According to the most accurate measurements, Betelgeuse is about 400 light-years away, though some estimates place it up to 600 light-years away. It is the fifth brightest star in the sky, excluding the Sun, and its brightness fluctuates occasionally. It reaches a brightness level similar to that of Riel, the fourth brightest star in the constellation. Pulsations, although not as strong or frequent as those of Maya, cause these fluctuations. A star might temporarily become exceptionally bright. Such stars are rare and extremely bright, created when a star explodes violently, ending its life. It is possible for a supernova to be bright enough to be seen during the day, though this has rarely happened in the past 1,000 years. Astronomers eagerly anticipate witnessing a nearby supernova, a rare event that few people will ever see. Betelgeuse has been considered a potential candidate for such an explosion since the early days of astronomy due to its brightness and visibility. As a result, we have accumulated significant information about it, including that it is much younger, less than 10 million years old, compared to the Sun's 4.6 billion years or more. We also know that massive red giants like Betelgeuse have short lifespans because they quickly consume their fuel. Thus, although Betelgeuse is relatively young in cosmic terms, it will soon end its life in a spectacular fashion. Despite predictions that a star might burn out any day now, it could still persist for much longer than a human lifetime. In the cosmic scale, 10 million years is a brief period, and the next day represents 100,000 years. However, scientists have long suggested that Betelgeuse's grand finale could occur at any time. Stars many times larger than our Sun have the potential to collapse under their own weight and die when their hydrogen and helium supplies are exhausted. They then accumulate heavier elements in their cores, leading to higher temperatures and densities, ultimately causing a violent expulsion of their outer layers into space. Some predict that when Betelgeuse eventually explodes, it will be so bright that it will appear as a second moon in the night sky. Betelgeuse is a variable star, but in 2021, it experienced a significant dimming, darkening by nearly 60% over several months. It was later determined that a cloud of gas was responsible for this dimming. Stars like Betelgeuse continuously release dust and gas, and part of the star was obscured by a gas mass in the wind. The star's southernmost part was found to be missing. Some stars, including Betelgeuse, exhibit behavior similar to weather patterns. Betelgeuse is now 50% brighter than usual, but the cause of the sudden brightening is unknown. It does not appear that a supernova is imminent. The brightness variations could be due to the same dust cloud that caused the previous dimming, reflecting light back toward us. Despite this, astronomers are excited because of the uncertainty surrounding Betelgeuse. The star is 15 to 20 times more massive than the Sun, and such massive stars are expected to explode as supernovae. Betelgeuse's current color suggests that its life is nearing its end, but it could still be 1,000,000 years away from exploding. For astronomers, 10 million years is a relatively short time, but it is a long period in human terms. New models have been proposed, with some suggesting a supernova could occur within a few thousand years, while others estimate 15 million years from now. The region around Betelgeuse remains mysterious, with its true mass and distance still debated. It is speculated that the star recently merged with a smaller companion, which might explain its faster rotation. Ancient manuscripts describe the star as resembling a yellowish Saturn due to its color change, implying rapid evolution and increasing the likelihood of a supernova occurring sooner rather than later. If Betelgeuse's supernova were to occur approximately 100 million light-years from Earth, it would be spared from any direct impact. The Orion constellation is known for its distinctive belt of 3 closely spaced stars, and Betelgeuse might become much brighter than its current prominent position in the night sky, possibly surpassing bright stars and even being visible during the day. This would be a spectacular sight to behold. Although rare, such events have been observed before. Eventually, Betelgeuse would disappear from the sky, but the explosion would create a stunning nebula. The light shell would not last long enough to form the so-called supernova remnants. The gas from the explosion could spread through space, reaching temperatures of tens of millions of degrees. The remaining material at the center of the supernova might eventually form a neutron star, a small, highly dense object composed entirely of neutrons, or a black hole, where gravity is so intense that nothing can escape its grasp. Betelgeuse, also known as Alpha Orionis, is a red, notable, and massive supergiant star situated in the Orion constellation. If placed at the center of our solar system, its outer surface would extend beyond Jupiter's orbit, making it one of the largest stars visible to the naked eye. Despite its size, Betelgeuse is an unstable star nearing the end of its life cycle, making it prone to exploding as a supernova at any moment. Betelgeuse has intrigued astronomers due to its immense size and variability in brightness. Recently, the star exhibited unusual behavior, particularly a significant dimming event in late 2019 and early 2020. This event, referred to as the Great Dimming, saw Betelgeuse's brightness decrease to levels not observed in over a century. Although it has since returned to its normal brightness, this event has sparked considerable speculation about a potential supernova. The possibility of Betelgeuse exploding raises many questions. Will we witness this event within our lifetime? What would the explosion look like, and what impact might it have on Earth? To explore the technology behind Betelgeuse's potential supernova, we look at insights from experts like Brian Cox. Cox highlights that the universe is a finely tuned system, and events like supernovae can have far-reaching consequences. Understanding these cosmic events provides valuable insights into the life cycles of stars and the dynamics of the universe. Betelgeuse is relatively young, around 8 to 10 million years old, but red supergiants like it have short lifespans due to their rapid consumption of nuclear fuel. Once Betelgeuse exhausts its hydrogen and helium, it will start fusing heavier elements until its core can no longer support the gravitational forces. This will lead to a catastrophic collapse and a spectacular supernova explosion. Supernovae are among the most energetic events in the universe, capable of outshining entire galaxies for a brief period. If Betelgeuse were to explode, it could become extremely bright, potentially rivaling the moon's brightness in our night sky and possibly being visible during the day. The explosion would create a brilliant light display lasting weeks or months. Despite its dramatic appearance, a supernova from Betelgeuse would not pose a direct threat to Earth. At approximately 700 light-years away, it is far enough to avoid any harmful effects on our planet. Instead, a Betelgeuse supernova would offer a unique opportunity for astronomers to study such an event up close, enhancing our understanding of stellar evolution and cosmic processes. Betelgeuse's fluctuating brightness is a characteristic of variable stars, but the recent unusual dimming was due to a combination of factors, including the star's surface activity and the presence of a large dust cloud that temporarily obscured its light. While some models suggest that Betelgeuse might explode within a few thousand years, others estimate it could take up to 10,000 years or more. In cosmic terms, this is a short period, but from a human perspective, it remains uncertain whether we will witness this event. In the meantime, Betelgeuse continues to be a subject of intense study as astronomers use advanced telescopes and technology to monitor its behavior, hoping to detect early signs of its impending supernova. Understanding Betelgeuse's life cycle and eventual explosion can provide valuable insights into the processes that shape our universe. In conclusion, Betelgeuse is a captivating and enigmatic star that could explode as a supernova at any time. While such an explosion would be a spectacular event visible from Earth, it poses no direct threat to our planet. Instead, it presents an incredible opportunity for scientific discovery and a deeper understanding of the cosmos. As we continue to study Betelgeuse, we can only await the moment when this massive star eventually meets its dramatic end. Stars like Betelgeuse serve as beacons of wonder and curiosity, drawing us to explore the mysteries of the universe. As we continue to study Betelgeuse, astronomers employ various methods to monitor its behavior and anticipate potential changes. One such method is through the use of space telescopes that observe the star's light spectrum in detail. By analyzing these spectra, scientists can gain insights into the star's composition and the dynamics of its outer layers. Additionally, observational data from ground-based telescopes provide crucial information about the star's variability and changes in its brightness over time. Researchers also study the surrounding environment of Betelgeuse, including the interstellar medium and potential interactions with nearby celestial objects. These factors can influence the star's evolution and contribute to the overall understanding of its life cycle. Moreover, simulations and models play a crucial role in predicting the star's future behavior and eventual supernova event. By inputting various parameters into these models, scientists can explore different scenarios and refine their predictions. The study of Betelgeuse not only enhances our knowledge of stellar evolution, but also helps in understanding the broader context of cosmic events. Observations of such massive stars provide valuable data on the formation of elements and the dynamics of supernovae, contributing to our broader understanding of the universe's formation and evolution.